Okay, so last thing we're going to look at for this week is 5.4 Part 2. And we're going to look at solving solving an equation that needs a logarithm. Okay, so we'll do that. We're going to look at using the graphing calculator to create what's called a power model. So something we're going to type in on the calculator. And we're also going to look at rewriting something using properties of exponents. So let's start with it. So I want to rewrite that using properties of exponents. When I'm done, I don't want to have any coefficients in front of the x, the y, or the z, other than the number 1. Okay. So what we're going to do is kind of reverse how you would have gotten to this, and kind of reverse it, go backwards. So let's start with this plus. When would you add two things together and put the answer in an exponent? What would have led to doing that? Adding two things together and putting that answer up in the exponent. Yep. Yep, so a to the power of 2x.
Plus a to the power of...
Not plus. Times. A to the power of 2x times...
a to the power of 3.
Yep. So yeah, let's just start with that. So if you had that, because you're multiplying things with the same base, you add the exponents. Now, when you subtract an exponent? Yeah?
Division.
Division. So what would have to go in the bottom there?
A to the z.
A to the z. Okay, so we've got one of them in terms of a to the z. So we got that. Now we've got to fix these top two. Okay, a to the 2x. That's a product. How would you end up with a product in an exponent? What would this have been before you simplified it? A to the 2x, yeah?
A to the x to the 2.
Right. It would have been an a to the x, which is another thing that they wanted us to use, to the second power. So that would have been the first one. How about the next one, a to the 3y? Yeah? So a to the y, okay, there's another one another expression they wanted us to use. Divided by a to the z. So it's really just practicing our rules for exponents. And we rewrote what we had originally in terms of a to the x, a to the y, and a to the z. Any questions on that? All right, so that's pretty straightforward. All right, now the next thing, we're going to solve a problem that we've already done before, the exact problem, same numbers, except when we did it before, we did it using the graphing calculator. Now we're going to do it algebraic. So it's the population problem, where we started with 50,000 people. It goes up 2.5% every year, and they want to know how long before we hit 100,000 people. Okay, so we did this exact question. I think it came out to like, I want to say it was 28, might have been 28.07 years. It was in section 5.1. We did it. Probably, we did half-life in that section too. It would have been before we did the half-life problem, but it would have been right around the exponential growth stuff. Okay, so there's our problem. And okay, first thing we need to figure out is what makes this exponential growth? Everybody tell me why is it exponential growth? Yeah?
The rate's positive.
Can you say more?
Like the population starts at a set number and then you were trying to figure out what it is at a high rate.
Okay, so yeah, so the population is, the key word there is what's the population doing? What's that key word that tells you increasing? right? So we know it's increasing, but what makes it exponential? Yeah?
It's by percentage.
It's by a percentage, right? If I said the population was going up 100 people every year, that's not exponential, that's linear, right? Just adding 100. When you go up by a percentage, that's exponential. Okay, so now we need our formula for exponential growth. I think we started out with something like population as a function of time. And does anybody remember in the exponential growth formula, what comes right after the equal sign? Yeah? The initial value. And then in parentheses, there was something. Yeah? A little bit more than the rate. It was a 2 when we did an example of doubling. This is not, the population's not doubling every year though, so we had something a little different. But we did have some where it was a 2, but not this one. Yeah? It's 1 plus r. Doubling is a 100% growth, so that's why doubling is a 2 there. And then one more thing we need. Right now, that's not an exponential equation because it doesn't have, yep, an exponent of, it was the time. Yep. Okay, so now let's fill all that in. So our initial amount is how much? 50,000. Times. Now, what do we have to do with the rate? It's 2.5%, but when we use it, we got to be careful. Yeah? Make it a decimal. So what's 1 plus that rate as a decimal? Yeah?
Is it 0.025?
So, and then plus 1 would be,
Oh, so 1.025.
yeah, I guess I kind of wrote that a little weird if I was going to ask you that. So 1.025 raised to the t. Okay, so there's our population as a function of time. Now we have to plug in the 100,000. Okay, is the 100,000 a population or is it a time? Bruce? It's a population, so that's going to replace the left-hand side. So we had 100,000. And everything we've done up till now was the same as when we did this problem in 5.1. 50,000. Okay. Now, if I was going to solve that graphically, what would I do next? If we were going to use the calculator. Yeah.
Minus 100,000 on both sides. Oh, wait, no, never mind.
Well, you could. I don't think it's how we did it, but you could get it equal to 0 and then do a root. I think we did it a little different.
Can you graph both sides of it?
Yeah.
Equal to y.
So you put one side in y1, then you put the right side in y2. You graph it. Anything else after we graph it? Yeah. Find the intersect. Okay. And where it intersects, I think it came out to 28.07. We'll see. Well, we're not graphing. So what we want to do now to solve algebraically, that's what we're doing algebraically, we want to get t by itself. Well, what's one thing we could do on both sides that would start to at least get some stuff away from t? Yeah?
Minus 50,000 on both sides.
So if you have this,
And divide by
you could minus 50,000, but we have to
divide by it.
divide them. So we're going to divide each side by 50,000. And 50,000. Well, oops, that doesn't cancel. The zeros cancel out. And I'm really left with 10 divided by 5, which is 2. And there, the 50,000 cancels out. Now, that's not a very big equation. Just 2 equals 1.025 to the t. But what makes this equation a little bit harder to solve, and you wouldn't normally see something like that in Algebra 1? Yeah?
There's a variable in the exponent.
There's a variable in the exponent. So we have to get rid of having the variable in the exponent. Now, one thing you might think of is, well, why don't we just change it from exponential form to log? Okay, we did learn that yesterday. And if you were to try that, what's your base here? Yeah?
1.02.
Yeah, the base is 1.025. And before we even continue, did I show you how to do a base 1.025 log yet? No. I've shown you how to do which two bases by pressing a button on the calculator. E and 10. Okay, we haven't done any other base yet. So if you finish doing this, logarithm equals the exponent. If you knew how to type that in on the calculator, that is the answer. But we haven't learned how to type in a base like that yet. Okay, so let's try something else. I don't want to have that t as an exponent. So there is a rule that says we are allowed to move exponents if you have a certain kind of expression on the right-hand side. What kind of expression do you have to have where you can take this exponent and move it somewhere? But you can only do it if you have this in your problem. And we talked about it yesterday. So we talked about it when we did the combining and the splitting properties. This is the third property. I want to deal with having that exponent. Well, I don't want to deal with it as an exponent. I want to get that t somewhere else. But I can only do this if I have something on the right-hand side. And right now I don't have it. Anybody remember? Well, what's something we did with exponents yesterday? If they were an exponent and we didn't want them to be in the exponent. We did what with exponents? Yeah?
We put it to the in front of it.
We put it in front of it. But you can't take the t and just put it in front there. Because that's missing something that needs to be there to use that property. What do you have to have on the right-hand side to use the property Corbin just mentioned? Yeah, a log. You can only put exponents in front if they are on an argument to a log function. There is no log function there. So then let's make a log function there. Just like you can take square root of both sides, you can square both sides, you can take the log of both sides. So let's do it. Take the log of what's on the left and take the log of what's on the right. Now the t is an exponent on an argument. So you can take the t and put it in front. And you've got log 2 equals t log 1.025. And when I took the log of both sides, I didn't even say what base I was using. I just wrote the word log. What base am I using there? Yeah?
10.
Yeah, you could really use any base. It's just 10 is a nice base because I have a button for it. I also could have taken the ln of both sides because we have a button for that too. Okay, but I took the log of both sides. All right, now I still don't have the t by itself. What would be my last step to get t by itself? What was that?
Divide both sides by log of 1.025.
Yeah, divide each side by log 1.025. That's gone. And there's your answer. So t equals log 2 divided by log 1.025. When you type it in, make sure you close the parenthesis after the 2. So log 2, close it, divided by log 1.025, and I thought it was about 28 That's what we got when we solved it graphically. It's 28.07 years. Okay. Any question on how we solved that? Okay. Kind of more importantly, it should give you an idea of how to type that in on a calculator now. Because I had a formula for t. The only problem with it was we don't know how to type in a base 1.025. Well, here's another formula for t. So what's in this box and what's in the other box, they're the same thing. So it should give you an idea of maybe how you can type in something where the base is not a 10 or an e. You do it just like that. Okay, we'll talk more about that in 5.5. That's the first thing we do. It's called the change of base formula. But that's exactly what I'm going to show you in that section. Okay, so any question on solving a population problem algebraically? Okay. So the last thing. So in Algebra 1, sometimes you learn about scatter plots, right? And sometimes you draw a line through the points that go through it the best you can. If you just draw that line by hand, that's just called a line of fit. Well, there's a formula you can use to find the line of best fit. And that's usually something you don't do by hand, but I think I showed you guys earlier on the calculator. Stat, calc. We talked about regression lines. I think we did, I don't remember which one we did, but I know we did these earlier. Okay, we did one type of regression. Well, we're not going to look at how to do a linear regression. We're going to look at a different kind of regression that would fit data like that. Why would a linear regression line be good for that data?
Because that's exponential.
Yeah, that looks more like something that's, at least it's curved, right? It's not straight. I would say if I was going to try to put a graph to it, I'd say that would be a pretty decent graph. Whether it's exponential or maybe it's half a parabola or something, it's not linear. Okay, it's a curve. So I'm going to show you how we can find a curve that fits the data instead of a line. Okay, one of them we will do by hand, and then we'll check it on the calculator, and then I'll do one more just with the calculator. Okay, the specific kind of curve that we're going to find is called a power regression. Okay, there's all different kinds of regressions you can do, but we're going to do option A. And it should be the same option if you're using one of my calculators as well. The option is probably off the screen. So when you press stat and then you go to calc, you're probably going to have to scroll up. You can scroll up or down. I think it's actually faster to go up. And then you'll come out at the bottom of the list. And it's option A. All right, so what does a power model look like? Well, it looks like that. That's the equation of what's called a power function. And when you look at that at first, it really doesn't have anything to do with logs at all. An answer might be something like this. Y equals 4.5 x to the fifth. And you're right, there's no log in that answer at all. Where the log comes in is we have to figure out, should we even use a power function to model the data? So they'll give you a table. And the first step is a power function a good curve for our data? The second part is, if it is, how do you find it? Okay. So logs are going to help us with the first part. Is a power function a good model for the data? Okay, so any question on the format of a power function, what it looks like? The two things you have to find are the A and the M. Now, if I wrote it like this, you don't have to write this part down. I just changed the A to a B. What does B usually remind you of when you're writing like equations? Anyone remember what the B is usually used for? Yeah?
Y-intercept.
B is usually used for like a y-intercept. And what about M? Slope. And that's kind of what they are. And you'll see how. All right. So let's write down the steps that we use to determine if a power model is going to fit our data. Okay, so first thing that's going to happen, they're going to give you a table of data like this. Okay, we're gonna do this one together. You have to take all the numbers in this table, and you have to take the natural log of each one of them. Okay. There's a quick way to do it so you don't have to press ln1, enter, ln3, enter. But you need the ln of every number in that table, and we're going to put those answers off to the side. Step one is we're going to make a new table, and it's going to be all the values that were in the old table after you take their natural log. So the natural log is the tool that you use to figure out if a power model fits your data. If you take the natural log of all your points and then you graph them and they don't look like they're in a straight line, well then we're done. That means a power model is not the right tool to use. If they are in a straight line, then we're going to continue and we're going to solve for, I called it A. I think the calculator uses a different letter, but I'll stick with the letter the book uses. So we're going to find the A. That's this part. And then after we find the A, then we're going to find the M. Once you have those two numbers, then you're done. You can write your final answer. So write your final answer in the format y equals ax m. Do not substitute in for y in the final answer. Do not substitute in for the m. I'm sorry. Don't substitute in for the y. Don't substitute for the x. Just the a, just the m. Any question on that? Now, how are we going to get the A and the M? That's what we need to look at. Let's take that formula. Y equals AX to the M. That's how your final answer is going to look. But we got to figure out how to get the A and the M. And I'm going to show you the formula we can use to do that. And it's basically another version of this. Okay. Let's take the ln of each side of that equation. So you'd have ln y equals ln ax to the m. I took the natural log of each side. Now, is there anything I can do to simplify ln y? Is there anything I can break that down to more? What do you think, Alex? What do you think?
Can you take the ln from each side? Like, simplify it?
Well, that's my question. Can you break this part down anymore?
I don't think so.
No. That's just ln y. There's nothing you can really break down from that. How about this side? Is there anything I can do to that side that we learned yesterday? Yeah?
Could you, what if you have two separate LNs?
Mhm.
So LN A plus times LAX.
Yeah. Now let's see what we did there. So we separated out the natural log into a sum of 2. And we put the m in the front. So now, if I kind of rearrange it a little, it's almost going to look like something you've seen before. Let me just write it off to the side. ln y. Let me write the other term first. M ln x plus ln a. What does that kind of look like? Yeah. Yeah, it kind of looks like slope-intercept form, where m is your slope, and the a part has to do with the y-intercept. Exactly. So this equation is what's going to help you when we have to figure out the a and the m. Okay. So I'm going to just put use this for steps 2 and 3. Now let's try a problem. So the first thing I want to do is determine if a power model is the correct thing to use. And then if it is, we'll go ahead and do the steps out to find it. So we're going to do this one by hand. We're going to check it on the calculator, and then we'll do one more just on the calculator. Okay, so here is the data. Now the first thing I need to do is take all those numbers and do what to each one of them? Yep.
The natural log.
Take the natural log. This is a temporary table. We're just going to put it off to the side. We're going to use it for one thing, and that's just to determine if the points look like they're in a straight line. Okay. Because I don't want to have to take the ln of 8 numbers separately, what I'm going to do is I'm just going to go to stat on the calculator. And after you go to stat, go to edit. It's the first option under when you press stat. If you have anything in there, highlight the numbers that are in there. And just press delete. Press delete. And that'll get rid of all the numbers. Yeah.
How do you get there, like, from the start?
Stat and then edit. Everyone else got there okay? Now, generally what you want to do, you don't have to, but I would do this. Put your x's in L1. Just like that. Now put your y's in L2. If you do it this way, it's going to save a little bit of time later. If you don't use L1 and L2, fine. But then we're going to have to fix something later. So 5, 2. Okay, so now I've got all my x's in L1, and I got my y's in L2. And I want the natural log of every number in those lists. So what I'm going to do first is I'm going to take the natural log of every number in L1 at the same time. So the way you can do it is press ln, and you want to press second 1. What that's going to do is take the ln of every number in L1. Second 1. All your lists are the blue values above 1 through 6. So that's a list of all the ln's in L1. They go off the screen, so I'm going to have to scroll to the right to see them. But let's write all those down. Okay, so ln x, ln y. Okay, so I've got 0, 1.1, 1.6. And does anybody have the last one that goes off the screen after 1.6? Yeah? 2.1? Okay. So that's ln of all the x's, and you only have to press ln once. Now let's do the ln of all the y's. What do you think I'm going to press to get the natural log of every number in the y's? All in one step. Yeah?
ln and then second 2.
Second 2. So that's going to give me the ln of everything in list 2. So 1.6, well yeah, that one should be the same because we had a 5 and a 5. So those are the same. So 1.6, 3.4, and if you scroll to the right, does anybody have the last two? 4.3, and the last one? 5.1. I don't really care about more than one decimal place because I'm graphing these by hand now. I can't graph more accurately by hand than the 10th. All right, so now we've got our table to see if it's linear. Any questions on the numbers in that table? Okay, now let's graph. Okay, so get your graph paper. Let's use this one. There. Let me zoom out. Okay, so we've got 0, let me zoom in a little more. 0, 1.6. So about right there. We've got 1.1, 3.4. So 1.1, 1, 2, 3, be about right there. 1.6 and then 4.3. So 1.6, 1, 2, 3, 4.3, be about right there. And then 2 point, a little more than 2, a little more than 5. So 2, 1, 2, 3, 4, 5. Put the dot about right there. Okay. So what do you think? Does it look like those dots are in a straight line? Yeah, they're pretty. I mean, I just did it by hand, but if you put a line through them, I mean, it looks pretty good. It's not bad. Okay, so that's all you need that table for. Now we're done with the ln table. We used it to determine if the points were in a straight line. Yep, they are. So now we're going to find the equation. Okay. So step 4 tells me there's 2 letters I need to solve for. What are the 2 letters that I need? I need A and L. Let's find A first. To find A, you're going to pick a point from this table, and you're going to plug it in. Now, there's a certain point that I would pick, because when you plug it in, and you're going to plug it into what we said right here, we're going to use that equation for steps 2 and 3. There's a point that if you pick it, one of the values comes out to 0. Which coordinate could we pick from the original table? And the only reason I like 0 is because it makes something cancel out. Yep. 1, 5. You right? Yeah. All right. 1, 5. So we're gonna plug in the point 1, 5 into this equation right here and solve for A. Okay, so let's write it down. ln y equals ln A plus m ln x. And we're plugging in the point 1, 5. That's x. That's y. So let's do it. ln 5 equals ln A plus m ln 1. Now normally this would be a problem because you have 2 variables. But what do we know about the natural log of 1? Yeah.
1 or 0.
0. So 0 times anything makes all that go away. And then this makes it pretty easy to figure out what a is. So the natural log of 5 is equal to the natural log of a. So based on that, what do you think a is? Yeah? 5. Yeah. There's your a. Okay, question on finding a. All right, now that we have a, we're going to use the formula again, but we're going to fill in a different point. It doesn't really matter which one you pick. In the last class, we picked the one without any decimals in it. Doesn't really matter. What's that? Okay. If this data is supposed to be modeled with a power curve, then any of these points would work. My only concern about using like this one or this one is were there more decimals after the 2 that they didn't write down, so we could have been more accurate. To me, it looks like these answers are probably exact because there's no decimals. So let's go with the 8 160. Okay, so now take your equation again. Fill in 8 160 and fill in 5 for a because now you know a is 5. So we're going to have ln 160 equals the ln of a, which is 5, plus m ln x. We don't know m. That's what we're solving for. But we do know x. X is 8. Okay. What would be our first step to get m by itself? Yeah.
Subtract ln of 5 from both sides.
Yep. So let's take ln 60. Bring the ln of 5 to the other side. All right. And now what would be our last step to get the m by itself? Yeah.
Divide each side by ln 8.
Yep. We're going to divide each side by ln 8. Okay, so the ln is gone. And now let's see what that simplifies to. Let's take the ln of 160. You know what? We should put an extra set of parentheses around the numerator. So ln of 160 minus the ln of 5. Okay, I want it to do that first. And then when it's done, divide by the ln of 8. All right, so that gives us our value for m. If you see a decimal repeat 4 or 5 times or more, let's pretend that it just keeps repeating and round like that. So what number is m really in this case? As a fraction, what number would m be? Yeah.
5/3.
Yeah, that's 1 2/3, 1.6 repeating. So that's 1 2/3, or if you write it as an improper fraction, m would be 5/3. Okay, so now we've got the 2 values that you need to write the final answer. It's like you've got your slope, you've got your y-intercept. What's the format that our final answer is supposed to look like? You don't have to fill in anything. Just give me the equation. It's y equals what times what to the what? Yeah.
ax to the power of m.
Ax to the power of m. So y equals 5x to the 5/3. That should be the equation that goes right through our points. Well, let's check it. The way we're going to check it, we're going to graph it. Okay, so we've already got our points all typed in, L1 and L2. What we need to do is go to y equals. And you can clear any equation that's already in there, but you need to turn on one of the scatter plots. That's how you're going to graph the points. So if you press the up arrow and hit enter, plot 1 should now be highlighted. Okay, that means you've turned on one of the scatter plots. Now, we already checked this in the last class, but if you press second, y equals, it'll tell you what it's using for the x values and the y values. It's using L1 for the x's, and it's using L2 for the y's. Is that where we put our points? Yeah. If we had used L3 and L4, fine, but we'd have to change these two things now. Okay, that's why I said put them in L1 and L2. And it's going to use blue dots. We could use red dots or black dots. The color doesn't matter. All right, so we've got our scatter plot turned on. Now I need to set my window. In my original data, what was the smallest x value they gave us? In the original data.
0.
They gave me a 0?
1.
1. Okay, so let's go with 0 then for the smallest. What was the biggest x value? Yeah?
8.
8? So let's go 10. What was the smallest y value? Yeah?
5.
5? Let's go 0. And what was the biggest 160? Okay, let's go 200. If you hit graph, there's your points. Now, type in 5x to the 5/3, and if we did it right, it should go right through those points. Or be pretty close. So 5x to the 5/3. It's not going to get too much better than that. That's about as good as it gets. So we found an equation that goes exactly through those points because these points were perfect for a power law. That's why I picked the ones I did. Okay, so any question on how we did that? All right, so now let me show you how we can get the same thing on the calculator. We already have all the points typed in. That would be step 1. Once the data is in there, go back to stat, go to calc, and does anybody remember the name of the option I showed you earlier? Yeah?
It was like power reg.
Power, yeah, stands for power regression. So we're going to do option A. Hit enter, and it's going to ask you where are your x's and where are your y's. Well, we put the x's in L1, we put the y's in L2. So nothing we need to change. So what we're going to do now is just go down to calculate. We're going to hit enter. Good, I got it just in time. On some model calculators, when you do power regression, that will pop up on the screen right away. Power reg, L1, L2. If that pops up, you just have to hit enter. On my calculators, you have to go down and calculate and hit enter. So it just matters what model calculator you're using. But it's pretty similar. And now, look at what it calculated. If we round it appropriately, what did the calculator find for A? 5. Yeah. And what did it find for B?
5/3.
Yeah, 1 2/3 or 5/3. So the calculator got exactly the same thing we did. Notice it doesn't keep repeating like 0.9 forever. That's because these data points probably aren't exact. What I'm going to do on the test is I'm probably going to give you 4 decimal places. So the data that I give you is going to be very exact. Right? It's not going to be just to 1 decimal. So you'll know what to round to. Okay, it's going to be very clear because you're going to have good data to work with. But I still think that's pretty clear what to round to in that case. Okay, any questions, especially on the calculator one? We'll try one more of those. Okay, so I'm not even going to ask you if a power model is appropriate this time. I'm just going to tell you it is appropriate. Let's find it. So to find a power model, we need data to work. We're going to use 4, 2816, 6.5, 31,908, 8.5, 122,019, and 10, 275,000. Okay, we're going to find a power model on the calculator. So what's the first thing that I have to do to find a power model using the calculator? Yep. Now, since I still have the same number of data points that I had in the last problem, I can just type right over. Okay, if I had a big list there, I would probably clear it first and then type them. Okay, so my x's are 4, 6.5. Okay, so we got the x's. And then in L2, we always put the y's. So you got okay. So now I got all the data in there. Okay. What do I do after I put the data in?
LN and then second L1.
So if we were going to check if a power model is the right thing to use, then yeah, you'd have to take the LN of every number in this list, get the new table, graph them. But I'm already telling you, there'll be a straight line.
Okay.
So now we can jump right to the step that comes after that, which is to do what?
Stat and then calc and then go down to A.
Yep, stat, calc, and then go to option A. Now, on some calculators, when you press option A, this is going to pop up on the screen right away. You're going to see this. If you see that, just press enter. And it would do what ours is about to do. On mine, before I press enter, I have to go down to calculate and then press enter. Okay, it's going to give us some values. Now I know the calculator is using a different letter for the exponent, but just pay attention to what number it says to put where. Okay. So the format that I think I use with you guys is y equals a x to the l. Those are the letters I used. Okay. So what's going to be our exponential, well, what's going to be our power function? It's not an exponential function, it's a power function. Yep.
2.75 times x to the power of 5.
Yep. It's x to the power of 5. And the last thing we'll do, just to make sure we did it right, is we'll check. Okay, what should we use for an x min here? 0, I think that's fine. How about an x max?
12.
Yep, I go a little past 10. How about a y min?
0.
Yeah, 0 is fine. How about a y max?
300,000.
300,000. Okay, so now you've got your points, you got your window set up. Type in your equation. 2.75 x to the 5th. And if we did it right, the curve should go perfect right through those points. And that's how you find a power regression. Okay. Any question on that? Okay, so Let me talk about the take-home test. If you're not in the room at the time I talk about it, you are still responsible for making sure you read everything about it. So, take-home test. So a couple things. It will open at 2:40 p.m. Eastern Time on November 21st. It will close at 8 a.m. Eastern Time on November 22nd. Ooh, I forgot an important thing. 2023. 2023. Yeah, it's on Edge Elastic. You will be able to use the graphing calculator. You will have to have a graphing calculator because there is a power regression problem. You're not going to be able to do the one I give you without the calculator. So you need the calculator. There won't be a password on it. You will have 100 minutes. So normally when we take a test, you have about 55 to 60. Okay, this you'll have 100 minutes, and it's 9 or 10 questions. We only did one section, so there aren't that many questions. You can work on it in any 100-minute chunk of time that you want. So if you did 40 minutes and then 60 minutes, that's okay. If you did 20 now and then 20 tonight and 20 tomorrow morning before 8 a.m., that's okay too. However you want to break up the 100 minutes. Every time you start again, the time remaining will show at the top of the screen. If you decide to pause it, I would submit what you have and close out completely, okay? Or save and exit. Okay? Don't submit until you're done. But if you have to pause it, I would save and exit. If you just leave it open and you just walk away, the time's just going to keep counting down. So close it out if you're not working on it, but don't submit until you're done. But if anybody doesn't think that they can handle that, if they just can't get it in by 8 a.m., or they're not sure about their internet, or they have to work tonight until 4 in the morning, whatever, then we can figure out something different for you to take. Is there anybody that does not want to do it as a take-home? Okay. If you don't work on it, it will submit itself at 8 a.m., so it'll be a 0 if you forget to do it. If you work on it and you forget to submit it, it'll submit whatever you did at 8 a.m. So it's going to submit whether you worked on it or didn't at 8 a.m., or you can do it yourself early. Is anybody not going to be here tomorrow? Okay, even if for some reason you are not here tomorrow, it is still due at 8 a.m. Right.
Is it all multiple choice?
It is not all multiple choice. No. In fact, it's mostly not multiple choice. Yes?
Is it going to be locked?
No, there won't be a password for it, but it will open at 2:40.
No, like, is it going to be like
You'll be able to use the calculator.
so I can go down the pad if I want to?
Yes.
Do it together.
Yeah.